Okay, so let's do this randomization test one more time. This time I'm going to use the Rossman Chance applet to do that. So here's the Rossman Chance applet collection. We want to go down to right here. Randomization test for categorical response, multiple groups. Click on that. And this takes me to, this will allow me to test between two proportions. First thing I want to do is the upper left, I want to change to 2 by 2. Then I'll enter that contingency table, which for us we had 21 males and 14 females were promoted, and 3 males and 10 females were not. And as important at this step, we click the Use Table. You'll see this this graph right here changes. That means we're doing it correctly. Down here in the bottom middle, 0.292, that's the point estimate. That's the difference between the males being promoted and the females being promoted. All right, now I'm going to go to the right here and say Show Shuffle. And now we can do our randomizations, our simulations. So let's say, let's go wild. Let's say make it 10,000. I'm going to pick 10,000 simulations. Shuffle. There are 10,000 simulations right there in the far right. Now 0.292 was about here. So what we want to do is figure out what proportion of these simulations match my original point estimate. So I'm going to count samples greater than or equal to 0.292 and a count. And you see I end up with about 2.5%. Now if I want to do it again, let's do another 10,000. Now you see I'm at 20,000. This count 2.5%. That means 2.5% of the simulations match up with the original sample. So that's about what, once in 20, not particularly likely, or once in 40, excuse me. So out of every 40 simulations, one of them matched up with my sample. Not particularly likely. So this is evidence that my sample is more than just random chance. That would mean reject the null hypothesis in favor of the alternative. Okay. So just to review some terminology, the null value is the value being claimed in your null hypothesis. For a claim of no difference, we'll always set the null value to 0. So this difference in proportions, random chance, the null value for random chance hypothesis is always 0. The point estimate is the value from the sample estimating this parameter, this difference in proportions. So in this case, we estimated the difference in proportions to be 29.2%, 0.292. The p-value is the proportion of simulations equal or more extreme than the point estimate. Essentially, it measures how likely the results of the sample could have happened by random chance. So, for my example here, this graph, the null value is 0. That's going to be the middle of the graph. And again, if we're doing random chance, difference in proportions is going to be 0. So that's going to be the middle of the graph. The point estimate is going to be somewhere else on the horizontal axis. In this case, 0.292, where the vertical red line is. And then all the bars that are above it, the point estimate, or away from the null value, that's what we call the p-value. So the p-value is the proportion of the graphs equal or more extreme than the point estimate. In this case, I end up about 2.5%.